So we are moving ahead from questions from new chapter, that is rotational motions. So we'll try to explore the questions. So I hope definitely this will validate to all of you. So we have questions. First question is the total energy of a particle that moves along a circular path is always positive, always negative, maybe positive or maybe negative, zero. So what will you have answer for these questions? So question is talking about total energy. Question is talking about total energy of the particles. Question is talking about total energy of the particles that moves along a circular path. Okay. Correct answer will always negative. Total energy particle that moves along a circular path is always negative. Next question, we are moving ahead. The following pair of physical quantities are analogous to one another in translatory motion and rotatory motions. That is mass, moment of energy, force, torque, linear momentum, angular momentum also. What is correct answer? Correct answer is on here. So here, okay, you have gone through all the concepts in the classes as well. Okay, so that mass and momentum is analogous, force and torque is analogous, linear momentum and angular momentum is analogous. This is analogous to each other. So we are moving ahead for next questions now. So next questions we have a vehicle is traveling along unbanked curved path with the friction between the road and the tires suddenly disappears, then the vehicle. Okay, so if the friction between the road and tires suddenly disappears, moves along tangential directions, moves along radially outward direction, moves along the direction between tangential radial directions. Outward direction moves along the same curved path. So what is correct answer? Moves along tangential directions. Okay. It moves along the tangential directions. Next question, we are moving ahead. A stone is rotated along a circle in a horizontal plane by means of a horizontal string at some height above the ground. If the string is curved, the stone moves along. Okay, the stone is rotated along. So basically, we are rotating along a circular horizontal plane by means of horizontal strings. String is horizontal, stone is like this. So we are rotating this one. Okay, and some at the some height from the ground. If the string is cut, so suddenly if you cut the string, so what will happen? What will happen? The radial straight lines, initial straight line, and if we are talking about the strings for the stone moves on the path. What is the correct answer? Correct answer is parabolic path in a vertical plane. Parabolic path in a vertical plane. Why? Because first it will go straight, but because of gravity, it will go down a projectile. So it will be parabolic now. Okay, it will be parabolic. It should become projectile. It should become projectile. So we are moving ahead for next question. Next question we have two particle pairs located at distance r of p and r of q respectively from the center of this rotating distance that r of p is greater than q. So basically radius of p is at a higher distance. P is at higher distance. You need to compare the acceleration. So p has a greater acceleration with the q than q. P will be we have a greater acceleration definitely. Why? Because v equals to omega r, a equals to alpha into r. If you talk about acceleration, so acceleration depends on r obviously. So if r is more, the acceleration will be more. We are moving ahead for next question. So the linear velocity of a particle at the north pole of the Earth due to its rotation is linear velocity of a particle at the north pole of the Earth due to its rotation is what is the answer? Zero. So linear velocity of a particle at the north pole of the Earth due to its rotation is zero. Next question, we are moving at when a car takes a sudden turn, it is likely to fall always from the center of curvature towards the center of curvature towards forward direction towards backward directions. When a car takes a sudden turn, so it is likely to fall always from the center of curvature, always from the center of curvature. Next question we are speeding occurs when the maximum frictional force of a flat road on a car is less than centripetal force required, more than centripetal force required, equal to centripetal force required, independent of the centripetal force, less than centripetal force required. The speeding is possible of a maximum frictional force of a flat force on a car is due to less than centripetal force required. When the maximum frictional force of a flat road on a car is less than, okay, so friction is less than, then speeding start. Okay, if the friction is less, then speeding start. Okay, then speeding start. So next question we are moving ahead. Next question we have consider the following two statements A and B. Identify the correct choice in the given choices. A centripetal force are equal in magnitude and position direction, but they not force of action and force of reaction respectively because both act on the same body. And centrifugal force is the pseudo force in both inertial frame of reference and non-inertial frame of reference. Centrifugal force pseudo force in both inertial frame of reference and non-inertial frame of reference. So correct answer will be first is true. Centrifugal force and centrifugal force are equal in magnitude and opposite in direction, but we do not force of action of the. This is not action and reaction. This is not action and reaction because it is we are talking about everything on the same body, same body. Okay, and centrifugal force is a pseudo force in both inertial frame of reference and non-inertial frame of reference. No, okay, centrifugal force when our object is accelerating, when our is accelerating. The pseudo force when we apply that when we are talking about non-inertial frame of reference, non-inertial frame of reference. Next question we are a particle moving along a circle with uniform speed. The following physical quantity constant both in magnitude and direction. Velocity, centrifugal force, and typical axis, angular velocity. Correct answer, angular velocity. The particle moving along a circle, so you know omega is going to be constant. Okay, both in magnitude and direction. Next, we are doing the sharpening of the knife with the help of grain stones. The direction of motion of a spark is radially outward or radially inwards along tangent in the direction of the rotation of the grindstone along tangent opposite direction. Correct answer is along tangent in the direction of rotation of the grindstone. Okay, so it will be along the tangent. It will be along the tangent. Next question, we are moving at a particle moving along a fixed circular path orbit with uniform speed. Then, which of the following is true? Angular momentum of particle is constant only in magnitude, but its direction changes from point to point. The angular momentum of a particle is constant in direction, but it's this. So correct answer only angular momentum of particle is constant both in magnitude and direction. So basically, when a particle is moving along a fixed circular orbit with uniform speed, then the following is true. Angular momentum of particle is constant both in magnitude and direction. Angular momentum of particle is constant in both in magnitude and direction. So angular momentum of particle is constant both in magnitude and angular momentum of particle is constant both in magnitude and direction. Next, so we are moving ahead. A uniform rope is rotated along a horizontal plane about vertical axis passing through one and with uniform angular velocity omega. If T is the tension in the rope at a distance x from the axis of rotation, then okay. So question is talking about T is the tension in the rope at a distance x from the axis of rotation. So T is the tension in the rope at a distance x from the axis of rotation. Then question is talking about T is proportional to omega square. T is proportional to omega square. T is proportional to omega. T is x square. The question talking about tension. Tension will be proportional to what is the correct answer? Correct answer will be A and D will be correct. So tension basically tension will be proportional to omega square because force is proportional to omega. So force is what M omega square or omega square or so force is proportional to omega square. If we are talking about tension definitely it will change with the x. It will change with x because if you come to this side, so a little bit more of this length and all this. Okay, so that's why if you are on the one and another end, it will be different. Okay, definitely it will be different. Next, because of the different mass. So we are talking about two particles moving and ever evolving, moving in a circular path having radius r. And if their time periods are same, then the rotation, the ratio of their angular velocity. This is easy questions. Question talking about the time period is same. Okay, time period basically time period is 2 pi by omega. So basically, what time period is 2 pi by omega, 2 pi by omega. Okay. So basically, what you do, so you know, moving in a circular path of radius r and r. Okay. Basically, you need to question asking you the if the time periods are same, the time period ratio of their angular velocity will be. So basically, ratio question talking about the ratio of their angular velocity time period is same. So basically, ratio of angular velocity is time period is same. So see, if you see T1 by T2, T1 by T2. So this will be what? If time period is same, then omega 1 by omega 2. That's all. Omega 1 by omega 2 time period is same. So omega 1 by omega 2 will be what? Omega 1 by omega 2 will be what? 1. So it will be equals to 1. Omega 1 by omega 2 will be 1. So it will be 1. Next question we are moving ahead. A vehicle of mass m is drive along an unbanked path of radius of curvature r with a speed v. It will be the necessary minimum coefficient of friction between the tires of a vehicle and road so that the vehicle is progressively speed then mu is proportional to b square mu. So you need to ask the relation between mu. So what is the mu relation of mu? Coefficient of friction between the surface. So that is mu is proportional to b square and mu is inversely proportional to r. Mu is inversely proportional to r. Next question, we are moving in a particular mass is revolving in a horizontal circle of radius r with the constant angular speed. The radius r with the constant angular speed omega. The aerial velocity of the particle is, you know, aerial velocity is what? Omega square r by 2. Omega r square by 2. Omega r square by 2. Next question, we are moving in a circular disc rotating along its own axis. Angular speed omega it is the exact midpoint of the disc between the axis and the rim of the disc. Then the angular velocity of p only. So it's very easy question. Basically, the angular velocity of p is then angular omega. So angular velocity is not going to change, that is omega. Next question, we are moving at a body of mass 0.1 to be moving along circle of radius 2 meter with a speed 4 meter per second. The work of a centripetal force during half revolution is so A mass is given, radius is given, speed is given. So work done by the centripetal force during half of the revolution is question to me half of the revolution. What is the work done? That will be zero. So work done by centripetal force in this revolution zero because it is displacement is tangential to the displacement is perpendicular to the force. Next question we are moving ahead. Next question based on torque and couple. So we are moving ahead. Relation in the rotational motion which is similar. P equals to md in uniform motion, then P equals to md. Okay, question is what? So question we're talking about P. So in place of PC, in place of P, it will become L. In place of it will become I. Or in place of B, it will become omega. L equals to I omega. So question is talking about, you see the options and then what is correct answer? L equals to I omega. So it's easy and doing question. Next question we are moving with the position of particle given by and its momentum is given by r equals to this, momentum is this, the angular, this is angular momentum r cross p. So if you do the r cross p, so this solve the r cross p. So how to solve line angles to the all the cases. So basically what L is what r cross p, r cross p, r cross p, line at equal angles to all the three axes. Okay. If you take the r, if you solve the r, so it will become angular momentum is perpendicular to x-axis, y-axis, z-axis. Okay. So if first you need to for this solving this question, you need to find out. Okay. Uh, uh, L equals to R cross P. Once you solve the L equals to R cross P, then you will observe that you will not, okay, the in perpendicular magnetic perpendicular, you will not get the value of x-axis. So you will not value the get out, you will not get the value of L I cap here. You will check it, you can check by yourself this process, and it will take some time. Sometimes I'm not solving it. You will see that there is no x-axis here, I cap here, it is perpendicular to x-axis. That's why I'm saying this is perpendicular to x-axis. For solving this process, you have to solve manually one by one. So you know how to solve the cross product. You can apply the basic process, you can solve the process. Next question, we are moving ahead. A body of mass and is projected with a velocity u, making an angle theta with a horizontal. Its angular momentum with respect to the point of projection after t second is L. Its angular momentum with respect to point of projection after 20 seconds. Basically, after t second, if it is L, so what is after 20 seconds? It's easy question, doable question, that is 4L. So basically, it's a proportional to t square. Angular momentum is proportional to t square. So your teacher already taught you, may have taught you in the classrooms. If you not, then try to learn these concepts that how angular momentum vary within time. Okay, so it's a basic concept of projectile and rotation. So basically, L becomes T square. That's why I'm saying if T is at a T equals to angular momentum is L. So at T, the angular momentum will be 2. And that is 2 T square. That is 4L. Next question we are moving at. The direction of torque is parallel to the plane of R and F. Perpendicular, it is obviously perpendicular R cross F. So, okay, so parallel to the plane of R and T, perpendicular to the plane of R and F. This is wrong. Okay, see, basically, let me say, this question. In this, okay, perpendicular to the plane of R and F. Obviously, because torque is what? Torque is R cross F. R cross F. Torque is what? R cross F. Okay, so perpendicular to the R and F. Okay. So next question we are moving ahead. Next question moving ahead. Next question we have, when a torque acting upon a system is zero, which of the following can be zero? So torque is zero, so means what? Angular momentum is constant. Angular momentum is constant. Next question we are moving ahead. The following equation is wrong. Tau equals to R cross F, A equals to omega B, a tangential, A R, A radial. So you already know this relation. If you don't know, try to learn this concept. So what is correct answer for this? D equals to basically this is omega r cross omega. So this is wrong. The following question is wrong. Tau equals to r cross f. Radial equals to omega cross d. And this is what? A tangential is what? Alpha cross r. So d is what? Basically omega cross r. D is what? Omega cross r. In that sense, we are saying it's wrong. So you should know this relation. So next question we are moving ahead. The direction of following vectors is along the line of axis of rotation. Direction of following vectors is along the line of axis of rotation. Angular velocity, angular acceleration, line axis of rotation. Question talking about axis of rotation. So you have options. This the correct answer will be angular velocity, angular acceleration, angular momentum, and torque all have axis of rotation direction. Next question we are moving ahead. During rotation of a body, the position vector is along x-axis and the force vector is along y-axis. Direction of torque will be along z-axis. So along that axis. So you can apply the cross product, you can get the answer for this question. Next question we are moving at the direction of position vector R is towards south and the direction of force F towards east and the direction of torque. To apply the torque cross product for correct answer only vertically upward. Next question we are moving at which of the following wrong direction of torque is final to axis rotation. The correct answer will be the direction of force vector is always perpendicular to the both the direction of position vector and torque vector. Direction of force vector, this is okay, this is wrong, this is wrong. Direction of force vector is always perpendicular to both the direction of position vector and torque vector. So this is wrong. So you can go through these questions again and you can try to learn the questions, what question is trying to ask. I'm moving ahead because I have to cover other questions as well. So next question, I'm moving ahead as circular path. Disk is rotated along clockwise direction because in the direction of torque is circular disk is rotating. So it's obviously vertically downwards, so rotating along clockwise. So apply right hand rule, and see check by your thumb that will vertically downwards. Next, we are moving ahead. So magnitude of torque is maximum in the following case. Question is talking about when the magnitude of torque will maximum and the radius vector is perpendicular to the force vector. When the radius vector is perpendicular to the force vector, when the radius vector will perpendicular to the force vector, magnitude of torque will be maximum because why? Why? Because theta will be 90 degrees. Next we are moving at constant resultant torque is rotating a wheel about its own axis, then following is truth. So constant resultant torque is rotating. So constant resultant torque is given as angular acceleration of fluid is constant. So if torque is constant, if torque is constant, torque is constant means angular acceleration is constant. Angular acceleration is constant. This is very important concept. This is very important concept. Next question we are moving ahead. A wheel is free to rotate about its own axis without friction. A rope is wound to the wheel. If other end of the rope is pulled with rod constant force, then the following is true. So this correct answer will be constant torque is produced and the wheel is rotated with constant angular acceleration. So basically, what we are doing, the wheel is free to rotate about its own axis without friction. The rope is wound the hook. So if other end of the rope is pulled by another around constant force, then following is true. So constant, basically constant torque is produced and the wheel is rotated with a constant angular acceleration. This is a good question. So you should know how to do this question. Next question we are moving ahead. The following pairs of the physical quantities are not analogous to each other in a translative motion and rotational motion. So which is not analogous? Force, torque, mass, momentum, inertia, couple torque. So couple and torque is not analogous. Linear momentum, couple and torque is not analogous. Next question we are moving ahead. If force vector is along x-axis, radius vector is along y-axis, then directional torque is, again, I did already this question. You can do this question to apply cross product along negative z-axis. Next question we can do wheel of radius r is to rotate about its natural axis and I is moment of inertia if tendency of effect is applied on the wheel along its rim when okay angular acceleration of the wheel is angular acceleration. Question talking about angular acceleration. Basically, there is a wheel of radius r is free to rotate about the natural axis and I is its moment of inertia. I is moment of inertia and tangential force F is applied to on the wheel. Tangential force F is applied. I is the moment of inertia. R is radius along the rim. Then the angular acceleration of the question is talking about angular acceleration alpha. Question is talking about angular acceleration. So, question is talking about angular acceleration. Correct answer is so you all of you know tau equals to what? I into alpha. You can say tau equals to what? I into alpha. I into alpha. And tau is what? R cross F. Basically, you can say R into F divided by I equal to alpha. Think like this, okay? R into F divided by. So which options is coming for this question? So you can think like this. You can correct it. The correct answer will be second one. Okay. So next we are moving ahead for next questions. We have a triangle metallic plate ABC uniform thickness made of rotate about an axis perpendicular to the plane of the plate by application of force F. See, you can see the direction of force. I'm putting the force here. I'm putting the force over here. Insect midpoint on the AB shown in the figure. If alpha 1 and alpha 2 angular acceleration of the plate when axis of rotation passing through AB and a and B respectively. If the axis of rotation is A, then angular acceleration is alpha 1. And when axis of rotation is B, passing through B, then angular acceleration is alpha 2 respectively. Which of the following is correct? The question is talking about, okay, which of the following is correct? Okay. Which of the following is correct? Okay, so basically F is applying, we are applying at the exact midpoint here. So what is the correct answer for this question? Alpha 1 will be greater than alpha 2. Alpha 1 will be greater than alpha 2. This is a big question. Try to think, you will understand more of this question. Next one will moving a uniform meter rod consists of a half tube and remaining steel as shown in the figure. Alpha 1 is the angular acceleration of the rod about 4. So alpha 1 is the angular acceleration of the rod about O, while force is applied as shown in the figure when force is applied. So alpha 1 is the angular acceleration about O. And here as alpha 2 is the angular acceleration about O1. Angular acceleration about O1 and alpha 2 when force F is applied as shown in the figure B. The following choice are true. Question is which of the following choice is true. Question is which of the following choice is true. So in this okay in this options you see okay alpha 1 is alpha 2 alpha 1 alpha 2 alpha 1. Basically if I will ask you if I will ask you acceleration is equal to R into alpha yes or no? Acceleration equal to R into alpha. Acceleration equal to R into alpha. So what is correct answer? So if you see alpha 1 will be less than alpha 2. Alpha 1 will be less than alpha 2. Because if you see torque is what I will tau, and if you see the moment of inertia, if you check the moment of inertia also, the moment of inertia, and then compare it, you will get the answer for this question. This is a good question. Next question we are going the circular wheel rotating in a cylinder in the rotation about it. The body is generally attached to the rim of the wheel when the following is followed. So this again is a basic body. So this is very good question. Angular momentum increases, but angular velocity remains constant. A circular wheel is rotating in a horizontal plane without friction about its axis. Its body is generally attached to the rim of the wheel, then to the oh, okay, yeah, false. Question talking about false. This is wrong. This is wrong. Moment of inertia increases, but angular momentum remains same. Angular velocity decreases, but the angular momentum remains same. Rotational kinetic energy decreases, but the angular momentum remains the same. This is false. Yeah. So next question we are going to next question we have. So on the moment of inertia, so a uniform metal rod is rotated on a horizontal plane about a vertical axis passing through this one and at a uniform rate. The tension in the rod is same at all points, different than this. The question is different at different points and maximum at the axis of rotation. Tension in the rod will be a uniform metal rod is rotated in a horizontal plane, so tension will be maximum at the near the axis of rotation. Next question, we have a boiled egg and a raw egg of same mass and size are made up to rotate about their own axis if I1 I2 moment of inertia. Boiled egg, raw egg. So following is correct. I1 is I2. This is easy question. So it's very easy question. So basically I1, okay, inertia of a boiled egg, I1 will be less than I2. Why? Because in raw egg, all the mass will be concentrated in the outer portion because centrifugal force. So it will increase the moment of inertia. It will increase the moment of inertia because of distancing. Because of distancing, we can think this is very good question. We can solve it very easily. We are talking about momentum. Okay. So yeah. Next question we have I1 I2 momentum is have two solid sphere of same mass, but I actually passing through their centers. It first is made up of wood and second is made up of steel. Then again it's easy questions, anyone continuous questions. The first is made up of wood and the second is made up of steel. Okay. So I1 a momentum is of two solid spheres. First of all, what is momentum of solid sphere? That is 2 by 5 mr square. 2 by 5 mr square. 2 by 5 mr square. So if you see the wood and the circuit is made up of steel. Steel, all the masses, heavy masses will be nearby the axis. Nearby the axis. That is the reason its momentum will be less. Okay. Next question moving is raw and boiled eggs are made of smooth or smooth level by applying the same torque, the egg that is spin faster. So spin faster is angular momentum is conserved, so it will whose angular momentum is less, that will okay. Whose angular momentum is less, whose means moment of inertia is less, moment of inertia is less, omega will be high. Omega will be high. Apply this concept, you will get the answer. Apply this concept, you will get the answer. Okay. When you apply that concept, you will get the answer. Boiled eggs. Next we have an ice block is in a rough surface which is rotating about vertical axis passing through the center when ice melts completely, the angular velocity of the system is. So this you an ice block which is rough through which rotating about vertical axis passing through its center when ice melts completely. When ice melts completely, angular. When ice will melt completely, what will happen? All the mass will become outer portion, and that's why angular momentum is constant. So omega will be what? L is what? I omega. So I will increase, so omega will decrease. Okay. So omega will decrease. Very good question. If you know the concept, then only you can do this. Okay. The question is talking about angular velocity will, okay, so correct answer is decrease. Okay. So you know the concept, then you can do this question easily. Next question we are moving ahead. The radius of gyration of a rotating metallic disc is independent of the following physical quantity, position of axis and rotation. So basically, the radius of gyration is what? I equal to mk square. I equals to mk square. Okay. So this relation, you know, then you can do this question easily. So what? This question, okay, is this. So mass of this and radius of this, so temperature of this, mass of this. So the radius of gyration rotating disc is independent of the following physical quantity. So radius of gyration, basically you see radius of gyration is what? Okay, I m. So basically, if you apply the moment of inertia, write the formula for I, so basically it will depend on R1 because M will cancel out. Now that's why I'm saying mass of this. Okay, that's why I'm saying mass of this. Okay. Next question, I'm moving ahead. A brass disc is rotating about its axis. If temperature of disc will increase, then it's the brass disc about its axis. Temperature of disc is increased. The radius of gyration increases, but moment of inertia remains the same. And this easy questions and doable questions. Here, radius of gyration, moment of inertia both increases. Why? But because brass disc is rotating about its axis. If temperature of disc is increased, you are increasing the temperature of this. You are increasing the temperature. It will expand. If it will expand, the more mass will be at the more distance. Okay, more distance. Okay. So R is also increasing. That's why. So both will increase. Okay. Next question we are have moment of inertia of thin circular plate is minimum about the following axis. The moment of inertia of thin circular plate. So these options. So axis passing through any diameter of the plate. Okay. So if the axis. So the question we have moment of a thin circular plate. If circular plate is moment of axis passing thin any diameter of the plate. Any diameter of the plate, axis will pass through any diameter of the plate. Okay. So then for moment of a circular plate will be minimum. Moment of a circular plate will be minimum. Okay. So you can apply this concept, you can get the answer. Next question we are moving ahead. So a uniform metal rod of length L and mass M is rotating about an axis passing through one of the and perpendicular to rod with an angular speed omega. If the temperature increases by T degrees Celsius, then the change in its angular velocity is proportional to each of the following. So basically, coefficient of linear expansion alpha. A uniform metal rod of length L and mass is rotating about an axis passing through one of which perpendicular to the rod with angular speed omega. So basically you are increasing the temperature. So what will happen in this? Okay, think that questions. Okay, we solve that questions. Next question is we have the moment of inertia of a thin square plate ABCD of uniform thickness about any axis passing through the center O and perpendicular to the line of the plate is. Okay, this is very easy question and doable question. ABCD uniform thickness about an axis passing through the center O and perpendicular axis of the plate. The moment of inertia. This is very easy question. So moment of inertia of a thin square plate of uniform thickness about an axis passing through center O and perpendicular to the plane of the plate. Okay. So basically, question is of talking about moment of inertia about this point, so perpendicular to the plate, perpendicular to the plate, perpendicular to the plate. Question talking about perpendicular to the plate that is I1 plus I3 like this I1 plus I3 is this I2 is this. So correct answer will be what? Correct answer will be I1 plus I3 is simply, and if you say I2 plus I4, say I2 plus I4. So basically, you can okay do I1 plus I3. Okay, so basically, what is happening here? What is happening here? This is uniform thickness of an axis passing through the moment of perpendicular to the plane of axis. So see, you can think on I2 plus I4 as well because this is perpendicular, and this is also perpendicular, but this is wrong. Okay. But yeah, this is also correct. Okay, so next questions we are moving ahead. For next questions we have, okay, in a rectangle ABCD, BC equals to twice BC. Basically, BC is twice of that is AB, and like this, the moment of inertia maximum along axis through the easy questions BC, AB, HF. What is correct answer for this? If you take the moment of say about AB, definitely moment of sorry, maximum. Why? First logic is if you rotate it, this length is very high. This BC is high. BC is high. So this is the first reason. Okay. This is the first reason because BC is twice. So length, so your idea should be to maximize the length. As much as the length will maximum, the moment of inertia will be maximum. Next question we have, okay, the radius of gyration of a rotating circular ring is maximum about following axis. Natural axis, this correct answer axis passing to the tangent of the ring perpendicular to the plane of the ring. So basically perpendicular to the plane of the axis passing through the tangent of the ring. This is the ring, so tangent of the ring, tangent, and if you perpendicular means like this, okay, perpendicular as well. So if perpendicular and tangent both, then our radius of gyration will be maximum. So I hope all of you understood everything. Thank you. Bye bye.